Hello boys and girls, welcome to another episode of FoulkesBrau. So today I thought I'd carry on with part 2 of our pointers and structures rewrite, and I wrote a little program just to demonstrate the power of using pointers. So what we have is we have our structure definition up here, and as I said before, this structure is actually 2468 185 bytes worth of data, each character being 1 byte. And what we were doing in the previous episode is passing a pointer to the structure. So we declared an instance of the structure over here, and then we had used it later on as pointers. All I've done here extra is I've declared a pointer to the instance that we've created, and I've got two print statements here. Basically, one to display the size of the instance of the structure that we've created, and the other one to show the size of the pointer. So if I run that, what we can see at the bottom, as we said, the structure size is 185 bytes and the pointer size is 8 bytes. Now it's 8 bytes wide because I'm running on Windows on a 64-bit platform, so that's 8 bytes. If you were running on a 16-bit system, it would be 2 bytes, and the same on a 32-bit system, it would be 4 bytes wide. So that is why the size is 8 bytes. But what is interesting to see is every time that we've passed a pointer to the structure, we are only passing 8 bytes of memory. We're not passing the whole 185 bytes, and that's the beauty of pointers. So anyway, to come back to our program, if you remember, what we did is we actually had them put in a string, and we had to do a bit of work around that string to basically calculate a checksum, and that was it. We were happy, and we had a bit of error checking. All we're going to do today extra is we're going to, because part of the task was to take that string and create a file. Now the beauty with C is that you can create different types of files. You can create binary files, you can create text files. So again, to keep this neat, we're going to write another function. I'm just going to call it, I don't know, let's say write to file. So we're going to say void write to file. And again, nothing fancy. We're going to pass it our pointer to our structure. So we're going to go struct of GPS data, and we're going to pass the pointer to it, my struct. Nothing really difficult there. We'll copy the prototype and we'll come down to our definitions, our function definitions down here. We take out the semicolon and we put in a pair of braces. Now, to write a file is actually very, very simple in C. The only thing that we need to be careful of is that we close the file stream if we encounter an error. So I need a definition, or a declaration, an instantiation, and I'm going to call it file because it is of the type file, and I'm going to just give it a pointer, and I'm going to call it, I don't know, output file, and that is it. It's really all we need to do. What we need now to do is get the user to input a file name for us. We obviously want to check. So I don't know, why don't we come back to our structure, and we'll keep everything to do with this structure complete. So we're going to put, I don't know, we'll put the file name in here. We'll call it, it's of the type character, it's going to be a string obviously. We'll call it file name. I don't know, let's make it 100 bytes. Very simple. So we'll prompt our user to enter on a new line, obviously. Please enter a valid file name. Obviously this has got to be in semicolon. What are we going to say? A valid file name of the type text, because we want to make sure that he enters a text file. We'll put a bit of error checking in because we don't want him to write binary files. I mean, we don't want to sit and decode this here. And we'll prompt him, obviously, to enter. We prompted him, now we'll get the file name. So we'll ask him with scanf. And obviously what we're looking for is a type string, so %s. And where we're going to put it? Well, my struct dot file name. That's simple. But like I said, the user can execute anything. He can put in a binary file there, he can put an exe file, he can put whatever the heck he wants, she wants to create this file. So we need to see if the file name is valid. So there is a very nice way of doing this. We can actually, because we've asked him to enter the type text, we can go in the string to that last full stop that before the txt, so the dot, and we can compare if he's actually entered a valid string. But to get that last character, in other words, what I'm talking about is this dot here, we need a pointer. And so again, to keep it all together with our file, our GPS data structure, I'm going to put it in here. I'm going to declare the type of a pointer, and I'm just going to call it extension pointer. So what we will do is we'll come down here, and we're going to check if this is valid. So how do we do that? We do it with my struct dot extension pointer. So again, like I said, we're going to point this and find where is the last occurrence of this dot. So we can do that with this string, return the character, return the pointer to where this character is last found, and we want my struct dot file name. And what are we looking for? We're looking for the full stop. All we've done here is we've said, listen, give me a pointer to where that character last occurs in the whole string. Nothing fancy. Again, in C we've got a nice thing called, we can compare strings, but it will give us the result as an integer. So I'm just going to put here, not there, I'm just going to declare in this function something called result, and we can say we want result to be equal to string compare what are we comparing? We're going to call my struct dot extension pointer, and what are we going to compare that? Well, we're going to compare it to txt. Very simple. So all we're doing, we're going to look at that whole file name, compare what is left after that pointer, and does it match this .txt. Nothing fancy. Of course, if it returns a result, that means it doesn't match. So if it returns anything other than 0, then it's not a match. In other words, the user did not enter a valid extension. So we can put a bit of checking. We say if the result is not 0, what do we want to do? Well, again, I've missed the brace. We're just going to prompt the user to enter. We're going to tell him they've entered the invalid extension. We're going to prompt them to do it again. So we're going to say do something while, and of course we're going to keep doing that while the result is not 0. So in other words, we're going to keep prompting the user to enter a file name until they enter a valid file extension. Okay, so what are we going to do? We're going to tell him that obviously invalid file extension and we can actually show him why it's invalid. We're going to say %s on a new line, and we're going to return my struct dot extension pointer. In other words, the string that we've pointed to, where we went and looked for this the last occurrence of this full stop. Well, just give me the string that you've entered invalid. Okay, so again, spelling. So we can say, well, listen, you've done the wrong thing. We've told you that you've done the wrong thing. Please enter the right thing. And obviously we need to do our error checking here again. So all very, very, very simple. We are just prompting the guy, please give us the right thing. And if he has, well, we can just, I don't know, let's do this. If he's entered the right thing, well, let's just display that. And we'll say, the file extension, instead of invalid, we'll just say the file extension is that thing that we've got after from our pointer. Okay, now here comes the difficult bit with writing to strings. We have to put a bit of error checking. So we've created this output file pointer. All we're going to say is if output file is equal to, and here's where the file stream comes in. We want to open a normal F open, my struct dot file name. I'm going to give it the switch, so that means write. So if the output file, I'm missing a bracket. So if output file of this whole thing is null, that means we have an error. Okay, so if this operation of fopen, so fopen will try and open a file, and because we're using the W switch, if it doesn't exist, it will create the file. But if there's any error in doing this, well, we have to do some stuff. And I'm missing a bracket. Yeah, that's that one, yeah. So if it's equal to null, well, let's tell them we've got an error. So on a new line again, we cannot open or create file. We want to tell them obviously what it is, so we'll put in the %s switch. We will tell them my struct dot file name. So what we're basically saying, there was an error opening that file. The important thing is we must close this stream that we've just opened. It's very, very important to close the stream. So that is why we're putting in the error checking, just to make sure if there's an error, close the stream, and we might as well just exit. And to do that, what did I type here? Exit 1. To do that, we just use this exit 1. Of course, to use exit 1, we need to be able to use another library, and it's in the standard library. Okay. So if there was an error trying to open the file or anything like that, we close the stream, we tell them that there's an error, and we exit the program. Otherwise, we can use this put string, file put string, and what do we want to write? We want to write my struct dot complete string to the output file pointer. Very simple. We might as well put in a new line on that, so we can use fput. C for character, and we're going to put, what are we going to put? \n, basically a new line character on the output file. And all we need to do then is close that stream again. And we will tell our user, hang on, the file was created successfully. So on a new line, file, we want to tell him what file, obviously, so the %s created and written to. And what file was it? Well, output file. And that is how simple this is. Obviously in our main function we'll need to call this, so we're going to say, what is it? Write to file, and my GPS data, and we are done. So again, I'm going to copy this struct. We'll go back to our little test program from before. If we run this again, we can see our structure is now 296 bytes. So again, passing the pointer to the structure is very important, especially if you're working with something like a microcontroller or something like that, where you don't have a lot of memory. On a computer, you don't particularly care, but on a micro you do. So you can see our structure has grown to 296 bytes. So if we clear this and we run it, let's see if we got any errors. Where in function main, let me exit this. Every now and then I've got an issue with it. Don't know why, but anyway. Okay, let's run our code. I can't remember what the whole thing was. 4916.12, comma north, comma 123.11.12, comma west, comma. So here's our prompt. So I'm going to say d colon backslash, I don't know, test dot, let's say bin. So you see it tells us invalid file extension dot bin. So let's say d colon backslash test dot txt. The file is created and written to. For some reason it didn't give me whatever the file name was. You can't see it. I'm just going to go here to my D drive. It's created the test.txt file. You drag it across, and there you can see it created our file and put everything in. And that is how simple it is to create and write to a file. It's really not difficult. So I hope you enjoyed that. It really is not difficult to use file streams or anything like that to create files. The big thing is that you need to check if you have an error, and that's basically all we're doing here. If this fopen function fails, if it fails, it will give you a null value. Then you know you have an error. Otherwise, you can continue, and that's all we're doing here. We're just saying, look, there's an error. We'll exit. I think there's the problem. Let us rerun that. I'm going to leave. Well, I'll show you the test.txt. You can see the string there. We'll put in a different value, so we'll get a different checksum. Obviously that's 1F. So let's run it again. 4913.45, comma n, comma 123.11.12, comma west, comma d colon backslash test dot txt. We'll put in a valid file name, and there we can see file d dot txt was created and written to, so I made a bit of an error, and we can see this time our checksum is **18. And if we open our test.txt, we can see it was updated, created. So again, file streams, very easy, but really what I wanted to demonstrate is the power of using structs, so keeping all these things together. And you can see every time we are just passing a pointer to that struct, and in other words what we were doing is we're basically passing this pointer to this every time. So we're passing those 8 bytes instead of passing the whole 296 bytes into the function every time. We're just passing the 8 bytes, and we're going back every time to this specific instance. We're not creating multiple copies of it in memory, and that's the beauty of pointers, especially with structures. Anyway, I hope you found that interesting. I hope you enjoyed it. I hope you learned something new. Of course, this is just building on where we're going in future, because like I've said before, the next block, we've got quite a few projects coming up. I'm not sure what the projects are, but I do suspect if we have a free hand in it, then there will be microcontrollers involved, and we will be writing some very nice C code, and we will be using this. Of course, there will be the electronic design portion. Anyway, until the next time, take care, be safe, and we will see you in the next one. Cheers.